Hello, Matthias.
Good morning.
Andreas, just let me know when everybody's in, please.
Everyone is just in right now.
Okay. Hello, everybody. So nice to see you online. And I would like to warmly welcome Matthias Steffens from Rhenus Projects sitting in Germany, who is kind enough to offer on his time a webinar and a masterclass for the THLG members for project cargo engineering and the importance of it. So, Matthias, thank you so much for joining us today. We are all ears.
Oh, yeah. Thank you very much for having me. Yeah, it was quite busy preparing the workshop. I had 2 weeks of vacation, but I think I managed to put something interesting for you together. And I also hope that you can participate a little bit because otherwise just talking in one direction is not what I prefer. Yeah, we will have a poll later on to see where the focus of this workshop is going, because this is actually up to you to decide. I hope I have so many monitors now open. I hope I will not talk too long, and we have maybe even time to talk about 2 topics or 3.
We can hear you.
I was on mute?
Yep.
Okay. If you're in a quiet atmosphere, feel free to make your mic open and ask questions directly during the workshop, because then we have a little better communication in both directions. So now I would like to share my screen. I'm hustling a little bit because usually we use Teams and not Zoom, but Andrea was so kind to give me a quick demo time earlier today. So all going well, you should now be able to see my screen and a little bit of me. Can you see my screen?
Yes.
Yes.
No problem.
So I was asked by the Heavy Lift Group and by Colin to talk a little bit about transport engineering. What is it? What are we doing? Why is it becoming more and more important? And we go a little bit into detail, but only on specifics. But firstly, we start with the general introduction that you know a little bit about what I'm doing here at the Rhenus Project Logistics and about myself. So the RPL Engineering is more or less an independent entity of the Rhenus Project Logistics. That means we also work directly for third-party customers. We work for smaller carriers who don't have an own engineering setup. We work for other freight forwarders, but we also work for manufacturers, shippers, and EPC directly. For example, on some GE projects, we work as their transport engineering back end, because after firing 100% of their engineers, they realize they don't have transport engineers anymore. Then we do this also for the surveying part for other customers. And we do this either on the Rhenus logo or for some customers, even on our white label services, which means you only see the Rhenus logo on the invoice, and all your customers and all the documents we present is on your logo and your layout, for example, if you want to book the services. So a little bit marketing and advertising we have to do before our presentation, obviously. So we do something different than the competition. For example, we have our live reporting. That means all our staff and our freelancers going in the port, they report in an app. You get a live link, or our customers get a live link where they can view on web browser, on their phone, actually more or less live what's happening in the port. They see the reports, they see the statement of facts, they see the pictures, they see the comments from the surveyors minutes after the cargo has been handled or minutes after the action has been taken, which is something we're doing already since 4 years. And the surveyors like it because there's no more reporting later on. The customers likes it because you have live feedback, you have the information directly, and not only with your PDF report 3 or 4 days after the operation. This is especially very interesting in short sea shipments. I don't know, many of you might have received survey reports after the ship was already discharged. This is a kind of interesting report if you have an insurance claim, but otherwise the time and money for that was in vain. Yeah, we do transport engineering, which I will come to later on what it is. That's the main focus of this workshop. We do it in a collaborative way, which means we try to include the manufacturer, the surveyors from the other side, the carriers, and find mutual solutions from the beginning. Not like everybody is working in different directions, but we like to work with everybody together because we all have the same goal, especially in engineering. A lot of the transport engineers know each other, even worldwide. So for us, the goal is to move the cargo safe from A to B. Who is in charge of what, who is paying for what is normally nothing the engineers consider and is not their cup of tea. We just want to drive everything solution. We are solution driven. So we want to make it happen within the frame we have, obviously, and within the contract. But we want to work with the other sides because it doesn't help us when we have a concept in mind and the carrier has a total different concept. Then we are not running in the same direction and we create more hassle than necessary. And then you end up receiving message statements in revision 21 or whatever, and nobody in the port is aware which is the latest and the actual revision which is correct. Our motto is always the best expert. As I just said, we also use freelancers, and this is not only because we are short in staff. This is mainly because our cargoes and the work field we are in, the project cargo and the heavy lift work, is so complex. If you have a guy who was working on project cargoes and windmills for 10, 20 years, he is not an expert in handling 2,000 tons modules, which you put on a Ro-Ro deck carrier or on a flow ship like a roll dock. So we try to find an expert who really knows the cargo or the ship type best to have the best solution on the spot, because we don't want to have a surveyor who's just taking pictures, where in a case of a claim, he can say, okay, I saw it, I was there, here's the picture, here's the proof. No, we want somebody who can step in and say, stop, let's don't do it like this. This is dangerous, this is not safe, but I have a solution. Let's do it like this and that. And this attitude you can only get from expert personnel. And so sometimes it's much better, even if you lose some money by sending a freelancer instead of sending your own stuff, but then you are free of your headaches and you get the best experience. And all of a sudden, like you might have felt, we're also doing workshops and trainings. So just quickly a little bit about me. I started a little bit about 20 years ago after my time in the Navy, 2001, with a German carrier called Cargo-Levant as a shipping apprentice. Quite normal way in Germany to start in shipping. And after all the commercial, water clerk, operation, chartering, I went to university and studied shipping and logistics. And during university time, I figured it was good to work a little bit, and I went to Harren Partner, which was back in the days with the carrier J. Paulsen and Combi Lift, when Combi Lift was not a forwarder but a carrier with own ships. We started there in the I started there in the engineering team and also on the small project freight forwarder they had in-house, where we did engines to Mombasa. We've been there 8 weeks with the SPMT transport on the ground, made the heaviest transport in Kenya, because my boss always said, okay, come in a suit to the customer, in a polo to the office, and get your coveralls because you're going to the job site, you are young, I don't pay extra labor, which was very good for me. And I learned a lot. And later on, this career kind of focused more and more in the technical direction. I was doing a lot of chartering also for Hansa Meyer, for example, and also for the Deugro team, but mainly worked in the engineering field with carriers like BBC or Dship. during my career. Then I got certified as a Lloyds Marine Surveyor, as a full member in their team, and joined the Rhenus family in 2019, where I was asked to start up and own, let's say, branch within the project department, as I just say, for the engineering department. And we are doing this since, now nearly 6 years, or 6 years now. And we are a growing team, and also have a growing customer focus. So it's not only the Rhenus, which is our customer. It's at the moment, I think we are on a 60-40 split. That means 60% of the customers are external customers. So enough marketing, enough about me. Let's dive into the topic, unless you have any questions from the first couple of minutes. If I speak too fast or if it's too boring, just let me know. Otherwise, I will just continue talking. So what is transport engineering, and why is the term coming more and more into play the last years? It started way back 30, 40 years with carriers like Jumbo or Big Lift, who had really complex cargoes and not many competition on the market then. And they had their former captains coming to the office, consulting them how to handle the cargo. Because also the insurance companies and the shippers realized that it's too high value and too risky to decide on the spot what to do with their cargoes. If you have cargo which you produce for 1 year, and one guy decides, oh, I just lift it like I want to, and the cargo breaks down, you all know that you have a big hassle. So transport engineering is a really specific field, and it's not a wide field. It's a very small field in the engineering part. But what we always see when we talk to shippers and to construction guys, we don't really understand each other. Meaning a construction guy who's producing a module or an engine or whatsoever, or a crane, he has the focus of this machine working for this lifetime without any incidents, and they normally don't consider that this machine they produce has to be brought somewhere. So the forces acting on these cargoes during ship or road transportations must be considered. And this is usually nothing the construction guys do or others do. So that's when the transport engineering comes into play. So I just wrote down, sorry? So I just laid down a couple of bullet points. So sometimes we are professional overthinkers, Colin can tell you, and also many of you might know sometimes the transport engineer or the surveyor steps in and asks questions nobody has thought about, which can be the pain in the behind, but mostly it's because of a reason, because they have seen things go wrong or they experienced that this is not really safe. So sometimes it makes sense to listen to them. Stowage planning is one part. We have to look into the drawings and also sometimes tell the shippers how to make the drawings. Because as I just said, the guys from construction, they're also now working with more and more 3D modules, which they don't want to share because obviously they don't want any company to copy their products. So sometimes we have to tell them, okay, for transportation, we need a side view, we need a front view, we need a top view, we need the COG, we need the capacity of your lifting ice, and things like that, which the manufacturer normally doesn't think about. So we have to not only read the drawing, but sometimes also consult what the carrier, the stevedore, the crane operator, what they need to see in the drawing to be able to handle that cargo safely. We do road trips, which is route surveys, which can be either following a transport, making sure everything is safe, but on the other hand, also a feasibility study. Meaning you drive a road, you check what's the possible cargo you can move here. For example, you want to build a wind farm on the top of the hill. before you build the wind farm, you must be sure which nacelle, which tower, which blade lengths you can get up there. So then it makes sense to make an open route survey, a route study, and say, okay, what's the max? What can we do? What's the highest weight we can get uphill? What's the biggest dimensions we can go through the curves and things like that. We have to deal also as rulebook jugglers with a lot of rules. A big pain for us is always the DNV rules, because they are really widespread and it's a wide range of books and rules. They are good, but on the other hand, they're sometimes too narrow and too conservative, and sometimes it's really cracking your head what they are thinking with that rule and is this really necessary and things like that. So we are risk hunters. We're spotting risks, problems before they happen. As I just said with our surveyors, they better say stop and come up with a solution instead of waiting for the incident to happen. We are the middlemen. That means we try to work, as I said before, collaboratively between the shipper, the carrier, the stevedore, everybody who really touches the cargo, who gets hands on the cargo. We try to be in the middle and consult that everything is aligned, which also means writing the method statement or reviewing the method statement, making their comments, and then in the port also making sure everybody follows those. Yeah, the master of movement means, there is actually nothing where we would say this is not movable. Normally the problem is not for the engineer to move stuff. Normally the problem is more for you as a commercial guys to find somebody who pays for this, because we will always come up with a solution. If you like that money-wise is a different story, but everything is possible. And luckily I also have a commercial background. So some of the ideas I hear or I have in my head, I have to filter out even before going back to the commercial part of our customers. Otherwise, they would laugh at me or kill me directly. So just a summary of a few things, which is our main, there's a typo, which is our main in-house, there's a couple of typos. Sorry for that. Which is our main house work, which is the feasibility studies, consulting. As I just said, we prepare technical drawings of stowage plans, lifting arrangement, lashing arrangement, crane drawings, and we issue and review method statements. The second part, as I mentioned, is the attendance. And this can either be as a port captain, who is the link between the stevedore and the master and helps to load the ship at best. Or on the other side, as a surveyor, looking at it from another perspective, giving hints, saying stop, and making the survey reports for the insurance companies, for the carriers, for the heavy hauliers, and for the forwarders. So the importance of heavy lift and out-of-gouge cargo comes more and more into play as the insurance companies got more and more conservative. We regularly hear the word that also insurance companies now change a little bit the politics, where they say, okay, we reduce your premium, but therefore you have to pay your surveyors and find a surveyor, and we have to approve him if we like him, if he's okay with the experience, and send him out. Because the cargo values are getting higher, and on the other hand, the cargos are getting more and more complex. One big topic, of course, is here modularization. We hear it from ThyssenKrupp, we hear it from many other companies, trying to produce as many on the yard as possible in modules, and then later on the final destination, just collect the modules, put them on each other and onto each other, and then you're ready to go. Because this obviously reduces the time you have on the customer premises to erect your chemical plant, for example. On the other hand, you can do everything with the cheaper labor at place of manufacturing. And This results normally in modules not even being bigger and bigger and bigger and heavier, but also then this module gets onto this module, which then creates sometimes awkward position of the center of gravity. How can you lift this still? How is this handled? And that's where transport engineers come more and more into play. We also see transport engineers not only in the shipping industry for ocean carriers, but also on the road and on the site erection, where this gets more and more important. And I was asked a couple of weeks back to put up some guidelines. When is it recommended to involve a transport engineer? When would it make sense? So I said, maybe it's also good to share it with you. So when you have cargos, for example, with a unit weight above 100 tons, then you might consider consulting. If you have a 100 tons travel with the same layout and you ship him on a weekly basis, that's a totally different issue. But if 100 tons for you is a benchmark where you say, okay, now really heavy lift starts, then you might consider this. This number obviously is exchangeable with a different field of experience and partners you are working with. High value goods, as I just said, to mitigate risk, not only the high value, but also production times is one critical point where you might consider, okay, having a second pair of eyes or having consulting here to avoid damages or to avoid any risks might be beneficial. Equipment limits. If you have 25 tons of load and a 30 tons crane, this might not be considered a heavy lift, but this is really a critical lift because you're going to the boundaries, to the limit of the gear you're actually using. And this is not only for cranes, this is for trailers, lifting material. Every time you get close to the limits of your equipment, you might consider, okay, maybe somebody else should have a look, because is this calculation correct? Or am I even going over the limits without knowing it? So then it also makes sense. If you need alternative solutions, which you might need besides your project, because everybody is working on the same solution and you have too much competition, you say, okay, now we go outside the box. What are other ways to move the cargo or to handle the cargo in this and that locations? Then it might also be beneficial to use a transport engineer. Sensitive cargoes, I put especially transformers and brewery tanks. Transformers usually are exempted from the insurance policies and need to be addressed separately. And normally the insurance companies always ask for surveyors. Before you have a surveyor on site, it might even also be good to have a transport engineer look at the concept. And brewery tanks, they are also quite sensitive, but there are many, many more examples. I think you might even know more than I have in my head now. So when it comes to complex engineering, which is a 3-point lift, for example, or where you need 3 cranes, or the COG is, the center of gravity is totally offset and it needs to be rigged, then your transport engineer must be your first go-to, because then the risk of damaging the cargo or even risking a life is very high. If the counterpart, for example, has a marine warranty surveyor involved, then I would always recommend to use a transport engineer, because otherwise you are trying to deal with somebody who has a totally different mindset, which is just protecting the cargo and not focusing on the costs at all. And this fight can be really a pain. It starts at an early stage, and this will follow you, and this will end up in very, very high costs if you don't have a counterpart for the marine warranty surveyor from your customer. So on technical tenders, transport engineering can also be beneficial in finding new solutions, preparing documents, a little bit different than the competition. And lastly, obviously, surveyors and supervisions, as I just said, Sending the apprentice out with a good digital camera making pictures is one thing. Having somebody there saying stop and finding a solution is a totally different thing, because we all know it. Normally when shit hits the fan, we have Friday 1600. If the phone rings, we already know that's not good. And then if you have a change in plan and you need to write a management of change and nobody is able to read it, your equipment or your ship will be on demurrage at least till Monday or Tuesday. So then it's always good to have an expert on the ground to find a mutual solution with all the different parties involved. So as I just said, transport engineers get more and more important, but on the other hand, we see, only talking for Europe for the moment, I know in the US, I think the problem is equal, but I can't speak for Asia and South America. We have less and less qualified transport engineers at the moment. Just for example, for the Port of Hamburg, at the beginning of the year, I had 3 freelancers I was working with regularly. All shut down their offices now. And this is not because they were not working enough or there was not enough work. This is the opposite. Either an insurance company came to them and said, okay, we want to hire you. Here's your fixum, and you don't have to hustle from job to job. Or their biggest customer took them directly over, or they really went out of business due to the complex work atmosphere. Not because they didn't like the job, but some of the freelancers being 30 days a month on the road without seeing the family, and then being in risk of getting claimed, were just not taking it anymore and didn't want to hustle with that anymore. So in Europe, we also have the fact that a lot of the engineers and surveyors especially are a little bit older. And with 65 and plus running around up and down the ship and next to the trailer, there's nothing they're keen on doing anymore. So we have a decrease in experts. On the other side, we see also, for example, the crew member and the seaman on board becoming less and less interested in the cargo. This is due to the fact that you have very difficult situations nowadays on board. The crew got reduced during the bad times where the carriers didn't earn much money. The crew was reduced to the so-called safe minimum, which is obviously now the new standard. The minimum crewing recommended by the IMO is something you can do on a container ship and on a tanker to run the ship. But if you do that on a multi-purpose or heavy lift vessel where you still have the work in the ports, loading, welding, cutting, grinding, and all that other stuff, then safe manning is really critical, and many of those crew members are not interested anymore in the cargo. And we see less qualified and experienced staff on board. Also, some are leaving the ship and going on shore-based jobs, not necessarily in transport engineering, but for the customs, for whatsoever reason, for pilots and so on, and then leaving in that direction, which makes a big gap of experienced people. And this experience is very difficult in getting back. Nowadays, you all know the situation. If I talk to a guy from Generation Z and say, listen, come to me here, you can work 24/7 and see the world, but I can't guarantee you that you're home on your birthday or on your wife's birthday or whatsoever. That's a little difficult. Also the working hours, obviously, because the ships are working 24/7. They don't drop their anchor at 5 p.m. So it's difficult to get new stuff. And we are lucky to have some, but this will not be not getting better in the near future, I would say. So market outlook, I already said, in the transport engineering field, I see the demand is growing, and the demand is growing in line with the ISO standards and the HSE standards. Because the more or the higher the HSE standards or the demands from your customer will get, they want to make sure that the HSE standards will follow. They ask for a method statement, for a risk assessment. This has to be written, this has to be prepared, and this has to be reviewed, and also in the port with a surveyor or even with an HSE surveyor supervised. That means the stuff you need for complex projects for EPC has increased dramatically in the last years. I was talking last year to a guy from Ørsted, from the wind manufacturer, on a job site, and he told me when he started at Ørsted, they were a project team of 6 guys and built a wind park. This was the good old times for him. And now it doesn't matter if the nacelle gets bigger or if there are more modules in the wind park, because this is just the time which is then longer. And he said nowadays they have 60 people in the project team. And he said more or less 54 people pushing paper and inventing documents the other has to fill out, and the 6 people from the past are building the wind park. So all this you have to consider, and that's why I see a big demand or big increase in transport engineering and surveying market in the near future. You also see the renewables, the modularization we talked about, the cargo values are rising, the insurance companies with their demands are getting higher and higher, stricter and stricter, but I think you know that better than I do. So that was the theory part. Now we would like to come to the fun part. Actually, I was thinking of which topic I would highlight today, but then I thought maybe it's better if you decide which topic we focus on today. If we have enough time, maybe we can focus on 2 or 3 topics. Maybe we dive only into one. That's up to you, but maybe Andrea can start the poll. I will just read it to you. So the first 2 will be kind of a quick live demo. So on cargo securing, I will just open up our lashing tool and together we can lash some cargo. On the stowage planning, I will tell you a little bit how to stowage plan, and we do a stowage plan live. Reading and checking cargo drawings is a quick one with some bullet points and showing you some cargo drawings where you can learn what you need to have your shippers inside the drawings. Method statement essentials, just a quick overview what should be in a method statement. Guidelines and regulations, not my favorite one, I can tell you. Costs and benefits of experts, and then risk reduction strategies, which is all more theoretical. Oops.
Andreas, do let us know. Andreas, do let us know when the poll is concluded.
Yes, of course.
I can see it here. 65% at the moment took part.
Okay.
So I still have some time to take a sip of water.
We have now 15 out of 23 people that have participated, 65%. Let's give it a few, one more. Okay, 17.
How many you want to select everything?
Select how much you want, but if you want to focus only on one thing, then only select that one.
So it means you need to make 7 webinar, Matthias.
You have my number, right? You can call me later.
Okay, I think everyone who was to vote has voted so far. So maybe we can conclude the poll. One more person has voted. We have 18 out of 23 people. So maybe we could proceed and share the results with everyone. Okay.
Yes, please.
One moment.
The million.
So these are the results.
Okay, so how to read and check cargo drawings. Okay, and then we have a tie between method statement, stowage plan, and lashing. So let's see what we make from it. I will start quickly with the cargo drawings, which is not really rocket science, but to some people it is. Let's see. And here also, please let me know if you have questions. Cargo drawings. So there we go. Okay, reading and checking cargo drawings. For the cargo drawing, it is important to know what you're planning on doing. So more or less on a trailer transport or on an ocean transport or for a crane lift, you need the same information. And if you want to have a lifting arrangement, a proper lifting arrangement, or a proper stowage plan, a proper trailer transport drawing, you need a proper cargo drawing. I really love it when shippers come to me and say, okay, we want to have a full style method statement, but you don't get any cargo drawings because we are afraid of copycats. This is very interesting. Or they send you a cargo drawing in a really, really bad PDF quality. Christopher, you remember the engines from your area back in the days? Really bad quality, and you should make the most of it, which is very difficult. Then we end up making a kind of cargo drawing ourselves, which is for us no problem, but for the customer, because they pay us by the hour. So
Is that why you come and see us after?
Sorry, say again?
That's why you come and see us after.
Yeah. What we need inside a cargo drawing is mainly always the same. It depends a little bit on your cargo, especially here on the footprint size matter, but we will have a quick look in an AutoCAD drawing in a few minutes. So, of course, we need the total dimensions, length, width, height. We need the position of the center of gravity in the front view, in the side view, and on the top view, because this is what we always need for lifting. It doesn't matter how we lift, the center of gravity of the cargo will always move underneath our hook. And in a worst case scenario, this can lead to the fact that the cargo will be moving, and if some guy is standing there, then we don't even have a cargo damage, then we have a totally different issue. Luckily, I never had the incident where there was blood on the cargo, and I want to keep it that way. And the number one rule is, especially for cargo drawings, bullshit in is bullshit out. So the cargo drawings need to be accurate and reflect the cargo, and especially when you have packed cargoes. It doesn't make sense to send you a cargo drawing like, oh, this is how the cargo looked like 10 years ago, but we don't have a new drawing, and then you have a case fully packed, and you don't see the center of gravity, you don't see the lifting points, you see nothing. That doesn't help. So you need the information of the total unit weight, including packing and everything. Then sometimes you have the weight on the hook with a static and dynamic load. This goes too deep now. I will leave that out for a moment. The lifting points. Do we have trunnions? Do we have pad eyes? Can we sling around the cargo? Where are the strong points to lift? What's the size of the trunnions? If my trunnion is only 100 millimeters wide and I have a 150 millimeter lifting sling, then I can't squeeze it in. If the pad eye is too small for a 50-ton shackle and I can't get it in, I must use a smaller shackle. But if the cargo is too heavy for that, then it doesn't work and it's not safe. This is something we can identify at a very early point. inside these cargo drawings. Are shackles required? Which shackles are required? I just said. So dimensions we already had. The views, front, side, top view. Many people are now sending this 3D image, which is the so-called ISO view, which is nice to have a look on the cargo and to see a little bit more detail, but it actually is nothing which helps us a lot. The front view, the side view, and the top view, that's what we need. If you have cargo which is standing on special plates or on foot or on legs and has a decent weight, then you might also consider the footprint, which is a view from it's a bottom view. That means you have a footprint drawing. It's like the cargo flipped upside down, and you see the areas where the cargo is touching the ground. And from that, you can calculate your ground-bearing pressures. Additional notes, like lifting instructions. Please only use soft slings, for example. Or don't touch here. And things like that, which are really important. So now I have to see how I can switch to the other program. 1 second. Now you should see my AutoCAD, right?
Nothing changed.
Not yet.
Okay. I have to click a button first. Better?
Better.
Okay. So, in this case, we have an unnamed generator, for example, which is quite a good example for the cargo drawings. In this cargo drawing, you even have a lifting scheme. That means they tell you, please lift with a traverse. That means a lifting beam. This is the front view. We can do it a little different. Okay. On the front view, you already see it is compulsory to use a lifting beam because these lifting slings have to go vertical. They're not allowed to touch the cargo. You see the forces which are allowed in each direction to handle the cargo. Okay, here the forces, forward and aft 1G, transversal 0.8. This gives you already an indication. Sometimes if they are lower, this can also involve the position on an ocean vessel. The further you are forward on the vessel, the higher are the accelerations, or if you're on deck, they are higher. So this is something we can learn from that. But let's start from the side. So this is our side view. We see there's a case around it. What type of case whatsoever. We have 3 pad eyes here. One is obviously for lifting. And these 2 are for lashing. We can apply 15 tons. What does that mean? And in this case, that's a really good question because we don't know that. Is it 15 tons braking load? That means you can pull with 15 tons and the plate breaks. Is it 15 tons securing capacity? So this would be the first question then to the shipper. What 15 tons? Because are there safety factors inside or not? What we don't have is the diameter of the lifting eye here, which is now 70 millimeter. And if I have the cargo weight, just to make it easy, we now say it's 100 tons. We have a straight lift. That means we have 25 tons on each lifting point. Now I would need to check if a minimum 25 ton shackle, because if the cargo is tilting, it would exceed. So the next shackle would be a 35 tons then. If a 35 ton shackle will fit in that hold so that it looks like here. Sometimes you also find information like, please use this shackle. In this case, that means lifting shackle 25 tons. So here we have the information already. What we don't have is the information where is the center of gravity. Here it says it's 70 millimeter off. Is it 70 millimeter off from the front to the aft and from there to there? Which is for us not really important. For us, the distance of the COG is always important towards the lifting point. Yeah, come on. Okay, this is now a 30 millimeter difference, which is more or less nothing, which we would ignore. But sometimes you have difference in there. In a tandem hook configuration, this means one crane is carrying more weight than the other. In a single lift configuration, this would mean your cargo tilts. Actually, it would mean you have to change the rigging that your cargo doesn't tilt. But this is something you have to plan ahead then. So, but what I just said, what information we need. The information is additional information. How can we sling it? We have the traverse. What's the detail on the lifting points? The lifting points is required 25 ton shackles. So we have the cargo securing points. Here 5 tons, here 15 tons. Whatever these tons and definitions are, maybe that's in the documentary coming with the drawing. We don't know so far. We even have a small lashing sheet. So now we can make our lashing calculation and our lifting range, and based on that and see if it works, if we can fit it to that. On the other hand, we have, there was a logo on it. On the other hand, you see cargo drawings like this. The COG here comes from me, because with this cargo drawing, I received the COG in dimensions. Meaning, by the way, the drawing is just an old design, but the COG is now 4,150 from the one end of the engine, for example. So, and then you have to hand it in to position your crane hook and things like that. We have also here the positions on the lifting points, but in this case, I deleted all information, which means now we have to go back. Especially on the engines, there are some funny manufacturers who install on the engine 5-ton lashing rings, which is really nice for us transport engineers because a standard lashing chain on board a ship has 10 tons capacity. And you can't use half a chain, obviously. So that means you have to reduce the calculated strength of all your chains to 5 tons. But still, when the forces are exceeding due to bad weather or whatsoever, your chain will not break. Your lashing point from the cargo will be torn or breaking. So also here, we have no footprint. We see the cargo is touching only here and there. Now we would measure our touching phase, 810 by 1,780. And then we take it times 2, and then we have the square meters where the cargo touches the ground. So with the weight of the cargo, so we have 1.78 times 0.81. That's a square meter surface of 1 foot of one of these consoles. So we need to take it by 2. So 2.8 square meters is the area where the engine touches the ground. And if we now have it, let's make it a little bit rounder. 250 tons engines divided 2.88. That means you have a ground bearing pressure underneath that area of 86 tons. which is quite something. So that means maybe on the ship, you need to talk about load spreading, or on the cargo. On the premises, you need to make sure how you place it, load spread, what's your ground bearing capacity on the premises where you want to lift it, where you want to place it. Sorry, getting confused here. So, but this is actually all the trick when it comes to cargo drawings. When you have the information, side view, front view, top view, and you have a look, where's the COG? Is the COG inside? Do I have information on lifting and lashing points? Back in the days when I started in shipping, we had in each and every inquiry, we send it out from the carrier to the customer. The cargo must have suitable lifting and lashing points. Otherwise, we leave the cargo behind and claim it dead freight, because the cargo is not seaworthy for shipping. I know the times have changed a lot, and not too many carriers will leave cargo behind. But still, for the safety of the cargo, having the information about suitable lifting and lashing points at a very early stage relieves a lot of headaches, and is really beneficial for all your subcontractors, be it the stevedores, be it the crane operators, the heavy haulier, the carrier, whosoever is dealing and handling your cargo. Any more questions about cargo drawings? Because otherwise, then I would close this topic. Okay, what's the time? Do we have some more minutes? Or should we call it a day?
I think that unfortunately we don't have enough time to cover another section, although I would love to hear more about the method statement. I don't know if that's too big, is it?
I can just pinpoint or just throw the bullet points on the board. That should be a quick one, yeah.
Thank you.
If I find my presentation, there we go. So the method statement. You see my screen again?
Yes.
Okay. The method statement. Basically, talking in football language, it is our playbook. The method statement should cover from A to B, what are we planning on doing with the cargo. The method statement came into play 20 something years ago.
Déchargement 25-29 avril. Ouais, c'est ce que ça fait à peu près ça, ouais.
Andreas, can you mute Christoph? Yeah, great, thanks.
The basic idea behind the method statement was for the transport insurance company, before sending out a surveyor, or instead of even sending out a surveyor, having a look what they're actually doing with our cargo. How are they handling it from place of origin till final destination? And this is still the structure which you find in most of the method statements. Usually it is in a sequence where you can follow the transport in the logical order. Sometimes you have it a little different because things are alike, not to duplicate them, but also we prefer them starting at point A with the introduction. And the project overview, that the reader sees what's actually the content of this document, what's the content of the project, to get all the overview. Then you start with the cargo description, packing list, cargo drawings, maybe some specifications like pay attention, this cargo is highly sensitive or whatsoever. The transport routes, I usually separate the method statement in the chapters then on carriage, ocean transport, pre-carriage, ocean transport, and on carriage, with the different steps in between separated then. So, but then you have a full overview what you're planning on doing. You describe your vessel. So what type of vessel I'm using. The vessel data sheet, for example, is a good hint. You describe the crane's capacity if it's a geared vessel, the trailers you're using, the lifting beams, the spreaders. All the equipment you describe in there is usually by a marine warranty surveyor, for example, or by an insurance company, then later on commented with, like, do you have certificates for this? Do you have certificates for the crane? Are they valid? Do you have certificates for the lifting gear? Do you have certificates for this, for that, for this, for that? So that means if you just write in, we use some slings and a shackle, you can be sure somebody will ask questions because they don't find enough details to familiarize themselves with the project. Then, of course, with the vessel, you also have the stowage plan, or when it's on carriage, the trailer plan with the trailer stability, or in this case, with the vessel stability, where you say everything has been checked, cargo fits on board, it's all nice and smooth, and we can start the voyage. To start the voyage, you describe your lifting and handling procedures. It can also be by placing cases and moving small stuff with a forklift, then making a tandem lift, hooking on the gear, using this and that equipment, inserting your lifting arrangement based on the very good cargo drawing you received from your customers, obviously. Then you describe the lashing methods, the lashing gear used. You provide the calculations. For us, beside the lashing calculations, we always provide a lashing scheme or a lashing arrangement, because these Excel formulas and these lashing calculation plans, they are good for the engineers, they're good for the marine warranty surveyor, they understand it. But who is actually executing the lashing? It's either the ship's crew or the trailer operator, or it is the stevedores. Nobody of them usually have read the method statement. Nobody will follow the calculation based on an Excel sheet from your lashing. Give them a piece of paper showing the cargo drawing. Here's a chain, there's a chain, there's a chain, here's a stopper, and they can just do it by the picture. It's much safer. A picture says more than 1,000 words than having too much documentation and calculations. It must be safe, but for the actual handling, a picture and a drawing is much better than a text file or a calculation. So the risk assessment and mitigation becomes more and more important for the method statement. In some companies, this is passed on to the HSE department and is a separate topic now. Some still have it in their method statement. Some customers requested to have it in the method statement. And the part which blows the method statement a little bit up. Oh, sorry. I think my biggest method statement I ever wrote was for offshore station in the UK and then going offshore, and was like 680 pages, if I recall. So it was all documentation, calculations, and drawings, and also the risk assessment. So you describe the environmental limits. What do I mean with that? The environmental limits, for example, if you have a crane operating, this crane has a manual where it says this crane is not allowed to operate in winds exceeding this and that wind speed. Also, other materials might not be used. For example, if you're in the north of Canada and you try to work in -20 degrees, then maybe it's not a good idea to use poly lashings, because they will break if they get wet and things like that. So your environmental limits are also a part of the method statement. Compliance and standards. Which rules have you been following? The CSS code for lashing. Are the SOLAS rules followed? Do you have an ISO standard? Are there specific port rules you follow? And then you need a section. What is the revision number? What has changed for the next revision? What's the date of the release? And so on and so forth. So this is all the information which should be there, because I have so many situations where I run around in the port and having a method statement in revision 3 and the other party has revision 5 and the next party has revision 6. So always make sure you have the revision number and the revision release date on the document. But this also accounts for every lashing and lifting plan and every drawing. itself. So then usually we also have a disclaimer on it, but I think that's clear. That was just a quick one on the method statement. Sorry for taking more time. I thought maybe we can.
No, it's our pleasure. It was quite interesting to hear about the method statement because, that's usually where the freight forwarders also come in, and that's how we base our transport solution. So I believe that it was interesting for everyone. I don't want to take more of your time, but I do, however, have a question for you, and I don't know if anyone else has one. I don't know if you have another 5 minutes to spare for us.
Of course.
Great.
Of course.
Okay. So my question would be, who bears the risk, of what the engineers are suggesting? Like, for example, in the Marine Surveyor, they are on a consultancy basis without really taking a risk about everything. So, scenario A, you have an agent, you have a freight forwarder, and they try, to bring in the best of the subcontractors to do the job, and then they follow the plan as the transport engineer instructed that this is the way you should do it, and something goes wrong. What happens there?
Yes, the transport engineer in most of the cases I know is always a consultant. The guys physically handling the cargo, the train operator, the carrier, the whatsoever. They can receive the plans and they can refuse it, obviously.
Absolutely.
But if they execute a plan, that means they should have looked at it and approved it.
That's right. Yeah, I
And
thought so. Yeah, because usually it's
that's the
always
same. That's the same when you receive from a carrier lifting arrangement or lashing arrangement. In that case, the carrier is responsible. Yes, but if the plan from the carrier has been written from an external transport engineer for them, the lashing plan, it's still the carrier who's responsible. When you're talking about marine warranty surveyors, then sometimes it's different because they have a back insurance, sometimes because if they make changes, that's different. But surveyors, usual surveyors, cargo surveyors, and transport engineers are working on consultant basis, and you will always find that in their terms and conditions.
Yeah. Going to the diminishing workforce that you mentioned, would that mean that, would that mean that, no, let me interpret it somehow else. We see that the more and more demanding jobs are getting less and less, attention from, young people. They're not attractive. They are too demanding, as you said, holidays, birthdays, and so on. Would that mean that your costs will get higher because you would maybe have to pay more to people to hire them, and that would automatically fall to the service?
I can tell you, I just had my car in the garage for repairs, and I saw their hourly rate. So I would say the cost, especially when you talk about the risk, that's also one big point, because the cost for transport engineering are normally not in the projects included, and especially not with covering risk. The costs might raise. I saw costs rising for port captains and engineering in China last year. I see a little bit or very high costs in the Middle East area around Dubai, and I see high costs in the UK. But in general, it is still very limited. The issue with the cost of transport engineering, why they are so low, let's say, is due to the fact when the shipping crisis was, every carrier was giving to everybody a method statement, a stowage plan, a lifting plan, a lashing plan for free. So you see carriers like Jumbo, BBC, Big Lift, you name it, with engineering departments of 20 to 100 people. And knowing the usual engineering salary, this is something which is a very expensive hobby for them. Yes, they need it in-house, but not for every quotation, obviously, because for every booking, yes, they need it for their ships, but not for the quotation phases. This might turn to the external market, but I also had this feeling 5-6 years ago when Big Lift started charging money for pre-booking stages documents. I don't see the prices rising that much in the next years, not due to the amount of labor and qualification available in the market. No, this has more to do with, are you getting it somewhere else for free?
Correct, that's right. I don't know if anyone else has something to ask. Otherwise, we move forward. No, everybody's happy. Well, to be honest, it was a very precise and spot-on presentation, and maybe that's the reason you don't get many questions, because you covered more or less everything we would like as freight forwarders want to know. So I really, really appreciate your presence here today, Matthias. Thank you so much for doing another webinar for us. It's always you're always welcome in THLG, and it's always nice to hear and learn more from you. So thank you very much, and thanks everybody for joining today. Oh yes,
we also need to take a group picture.
I forgot that. Can somebody else take it, because I don't have a laptop today?
Yes, no problem. If everyone, please, could you turn on your cameras for the photo? Let's give it a few seconds.
Christoph, don't go away now.
Yeah, and if you have more questions, you can see me also in Rotterdam on the breakbulk, running around somewhere.
Great.
Let's give it a few more seconds if anyone else can open their cameras. Okay, we have a few more. Okay, I think that's all. Are we ready for a photo? Okay. Excellent.
Okay, thank you so much everyone for joining today to another very, very interesting topic that was covered through the THLG Masterclass series. Thank you, and have a nice rest of the day.
Thank you.
Bye.
Bye. Thank you.
Thank you, Julia. Bye-bye, everyone.
See you around. Bye. Thanks.
That's all.